NQueen Problem. NQueen Problem states that you are given a number n and you have to place n queens in a n cross n chessboard. If you cannot place n queens, then you just print out no. I'm creating two vectors of size n plus 1 and I'm initializing them with 0. X will keep track of the rows and Y will keep track of the columns, and we will put the values 1 in it whenever we are placing a queen in that row or in that column. I'm creating a vector of int and I'm calling it grid. The printGrid function will take our grid as a parameter and display its contents. The vector of int is actually a 2D array, and we can access its values by creating two loops from 1 to n. But I will also print the size of the vector x and the size of the vector of int grid. Because we have initialized the grid from 0 to n, so its size will be 5. Now we will place an if condition, and this if condition will check whether a queen is already placed in that ith row or jth column. And if the value is 0, then we will place the queen at that ij index. We will also have to update the values in x and y vectors. Now right now we're only taking care of the row horizontally and column vertically, so it will not be exactly how a queen should be placed. Now as the queen can also move and attack diagonally, so we'll also have to take care of that. For that we will create a function called diagonal check and we will pass it a grid and I and j as parameters. The diagonal check function will take care of the queens which are present in the row above us, which is from row 1 to row I minus 1. And the tags can come from I minus 1 j minus 1, I minus 2 j minus 2, I minus 1 j plus 1 and I minus 2 j plus 2. So to travel from all these indices, we're creating a loop which will go from 1 to n. This I minus k condition will take care of the top boundary for us. J minus k will take care of the left boundary for us. Now we're inside the boundary, we will have to check that if there is a queen present in that index I minus k, j minus k or not. If it is, we will return false, and we will also change the return type of this function to boolean. Here I minus k is taking care of the top boundary and j plus k will take care of the right boundary. So if we have gone through all the indices and we haven't found any queen, so it means that we are diagonally safe, so we'll return true here. Now as we can see that we have placed 3 queens in our grid, when the first queen is placed at 1-1 index. What if we place the queen at 1-2 index or 1-3 index? So we have to check until we can place all the queens in the grid. So for that I'm creating an outer loop which will go from 1 up to n and we will place the queen at that place. We also need a variable to count the number of queens placed in our grid, and we will initialize it with 0 and we will upgrade its value to 1 here. We will also increment its value whenever we are placing a queen in the grid. And once we are done with this ith loop, then we will check that whether the number of queens we have placed is equal to the number of rows. If it is, then we will break out of this loop. But if it is not, then we will have to set all those values back to 0. Number of queens placed, the changes made in vector x and y, and the R grid again has to set to 0, because what we are doing here is we are placing the first queen at first row and the column FQ placed, and then we are creating the whole grid according to it and then counting the number of queens placed. This is a lot of operation of setting back the values to what they were. Suppose we place the first queen at the index 1, 3. We will have to update x1 equals to 1 and y3 equals to 1. Here is the desired output on the right hand side of the screen, that all the 4 queens are placed. We don't need to count the number of queens because we're going to be solving this recursively now. So instead of making the whole grid and counting the number of queens, what we can do is we can check that can we place a queen at first row. So here we're passing the row to be 1, and then if it is true, then we will print yes, and then we'll print our grid. Else we will print no. This will be if we can make it. So what we're doing right now is passing our grid, and we're passing the row number. We'll change this to boolean. We have passed our grid, now we're passing the row, that where we want to place our queen. This is the parameters is same, and we will get rid of all of this. We don't need this. So right now what we're going to check that if the row we are at right now where we want to place the queen, is it greater than n? Suppose we have to place n queen and we are at row 5th. So that means we have placed 4 queens. So we will return true. If it is not the case, then we will have to place the queen in one of the columns. So this I is for columns, which will go from 1 up to n. And here what we will do is we will check that if there is an queen in our row or not. Is there a queen in our ith column or not? Or is our row comma ith index is diagonally safe or not? If it is, then we will place our queen there. Row comma I. We will upgrade the values of x of row equals to 1 and y of I equals to 1. Now, after placing this value, we will have to check that can we place a queen in the next row. We'll pass our grid, we'll pass the row plus 1 and x and y. So what will this do is this will tell us that if we place a queen at this index, can we place the queen at the next row? If we can, then we will return true, but if we cannot, then we'll have to change the values back to 0. So right now we're not making the whole grid, we're just placing the queen at some row, and then we're checking then can we place the queen at the next row. And this is it, this is the whole program. We will run this. Okay, there's one problem. So I'm printing the grid twice, so I will get rid of that. So here is our desired output. We placed 4 queens which are safe. So what I want to do right now is I want to show you whenever we're placing a queen what is the status of the grid. This way it will be clear how the program is working. If it is not true, then we will have to print not safe. We will revert the values and then we will again print the status of the grid. Okay, so first of all we have placed the queen at 1 index, then we have placed the queen at second row, third column. Then it has showed that it is not safe because we cannot place any queen in the third row. We cannot place it in the first column, we cannot place it in the second column because of the diagonal, third column and the fourth column. So we're going to remove that queen from the second row and we're going to place it in the second row, fourth column. And again it is not safe to place a queen at the fourth row, so we have reverted back. We cannot place it in the third row, third column because it is not safe. So now we have exhausted all the possible ways to place the queen, first queen at 1-1. So now we will place the first queen at 1-2. Then we placed all the queens and our answer is yes, and that is our final grid. Okay, let's check for the values 5. Okay, let's look for 3 because that would be no, because you cannot place 3 queens in a 3x3 grid. So the final output is no, as you can see here. And these are the statuses, like if you have put the first queen at 1-1, second queen at 2-3, and you cannot place anything in the third row, so you will go back. If you put it at the first row, second column, you cannot place any queen in the second row, so it is not safe. Okay, so this concludes it. This is the NQueen problem.